where you been, Mike? Oh, was he coming in here? Oh, okay. Oh, I'm just on see it. Won't have too many people, but yeah, yeah. Look forward. I ran into some of your teammates yesterday, Kevin and gentleman with the SRR1, Filipowski. Yeah, it's like, oh my gosh, SRR1, man, we're still talking about that, huh? Didn't fix that when I was there, admittedly. All right, still around. Really is. We should be getting started here in a few minutes. We're we're not in a rush. So thanks for coming by, man. Thanks, Jeff. I should tell you to come on up. Well, we got Joe. We got Joe. Joe. We were supposed to have Karen Van Dyke. I thought that would be awesome to have her here, because she's from, well, Department of Transportation. Like, ooh, FAA questions, huh? Okay. And yeah, it just might be you, Dr. Joe, and then I'll put Bill up here too, or maybe put Michael up here. Figure it out. Jessica's not here either. I don't know what the problem is. This is the one thing that didn't change in our schedule. Everything else has been floating around. Anyway, so thank you for being here. Oh yeah, Ion. I was a member there for a while. Oh, super duper. What's that? Oh boy, hope that was I wasn't so bad. Have a good book to listen to. It's okay. That's what I tend to do around here and in DC. Keep me from losing my mind and my blood pressure. Driving, I thought it was bad out here. Oh no, 1,000% agree with you. 100% on board with everything you're saying there. Yeah. Yeah, we still got 10 minutes. I thought we were going a little sooner than that. Bill was right, 9:30. My bad. It is. He said he put it up there at 9:30. I have to leave my jacket up here. You know what? Right here. Right here. That's what I just did. It's canned water. Yeah, no worries. Thank you. I am. I work for Yes, sir.
You know, when you start, you click that guy there, and then just go.
Okay. Sometimes I do F5. Not in this one.
That's typically with PowerPoint,
Oh, yeah.
especially when they keep doing
Oh, I
video
see.
stuff.
Yeah,
It's
yeah.
full screen.
There's another technique.
I think it's
that may
Control
work.
L, right?
Yep, Control L. I forgot that. Control L or that thing.
PowerPoint, F5 starting.
Yeah, I've been giving too many. Hey, what's up? I forgot that. Yeah, thanks. Thanks for this.
saw the questions, right? So we got another
You know what, I probably do need to look. I think I did.
juggling 1,000 balls. What's the big deal, right?
Hi, ladies and gentlemen. Thanks for being here today. We have one of our panelists is on her way, so we want to give a minute or two for her to get through the parking and get up here so she can be part of the panel. So again, thanks for being here. We expect this to run about an hour long, and if we have a few, I'll try. I know I have some good talkers on my left that even compete with me, Dr. Joe. But we'll try to have some time available at the end so we can take some maybe additional questions from the crowd. So just stand by for a few more minutes. Thanks so much. Just an update on our last panel member. She's parking right now, so I'll use the term hoping she can find a spot. Oh yeah, we'll give her another minute or two, and then we might just press. So Coach Bill Jew is making a motion for the mound to bring in the reliever here, Mr. Michael Berger, for Karen, who's from the Department of Transportation. Unfortunately, she's stuck in traffic between here and LA, and as I remember used to living here, that doesn't ease up anytime throughout the day, especially with everyone back to work. So anyway, when Jessica comes in, we'll just put her next to me, and we'll go ahead and kick it off today. Again, please, gentlemen, please sit down. We'll start. First of all, thanks for being here today. Worked with Bill Jew. I'm following Captain Andy Gibbons. If you don't know me, I'm a Senior Acquisition Advisor to ASN, the Assistant Secretary of Navy for Research, Development, Acquisition. Why you care is that my job is to advise RDA on the programmatic, strategic, and technical aspects of everything to do with moving data securely across the globe, and particularly transport as it pertains to space. And as we know, a lot of the PNT, position navigation and timing capabilities originate from space. One of my areas that I was focused on significantly when I was 170 was utilization and teaming with commercial, as commercial industry changes how we are moving data across the globe securely. And I got to say, you can use the term cloud, you can use the term ML, you can use the term AI, pick the coolest phrase that you know that lasts for about 6 months. The biggest change, I think, in the way that we're operating as a force, and the biggest force multiplier has been over the last 5 to 6 years, has been the utilization of proliferated low Earth orbit, and also the addition of other companies like Bill Jew just showed, taking advantage of space and moving data across space. That has changed the way we're fighting the war. I think more so than anything else that we've seen in the last couple decades. Again, I call it today the second space race. So we're very fortunate to be part of that. That being said, today's panel is, we like to use the term, Bill has taught me A2PNT. He kind of just added the assured and alternate position navigation and timing together to say A2PNT. I don't know if that's accepted yet, but I understand exactly what he means. So what I'm going to do is, to my left, I'm going to go ahead and let the gentleman to my left introduce themselves, starting with Dr. Joseph Robin, give them a few minutes, maybe a couple slides to talk about who they are and what they do, and then we'll move into the questions. So Dr. Joe, over to you, sir.
Thank you very much. It's always an honor to be here, and while this is a small group, it's better to have a small group of the right people than a big group of everybody. So welcome, thank you for coming. I serve as Chief Engineer of Link Global. In that role, I do a lot of different things. One is to kind of oversee a lot of the technical work, of course, and applications, a lot of relationships to this community, and in so doing, sort of bring a lot of years of experience that cuts across many things, big companies, small companies. I mentioned yesterday that I actually wrote 3 of the 4 proposals to the original primes for the first GPS program. So kind of cared about this for a long time. Link is a small company hoping to be a big company that is one of the pioneers of direct-to-cell, maybe the pioneer of direct-to-cell. And what we found along the way, which we'll jump into my first slide here, but before you change it, let me just go back and point to what was on the screen. So those are examples of our spacecraft. The one on the left is a stack of 2. Our plan in building the satellites of this size and shape is to be able to stack up a lot of them and launch a lot at once, which we proved out in the one there on the left a couple of years ago. And the picture on the right was taken by a camera on the transporter launch vehicle, Falcon 9, as we were getting ready to deploy, in that case, a single spacecraft. Next chart, please. So one of the things that's important is that there are three technologies that really touch each other, and we like to feel that we're a beneficiary of that in our approach to A2PNT or alt-PNT. And that is that communications is one of them, networking is the other, and the third one, of course, is the, let's just call it position navigation and timing. They can be taken separately, but in our case in particular, we're kind of unique. We don't approach this the way GPS approaches PNT. We don't do it with signals of opportunity. We don't do a lot of things, and we really treat PN as a separate entity and capability than time. And so I've got, following this, don't change it yet, I've got one on PN and one on T. That's kind of what makes us different. Our phenomenology is different, our strengths and weaknesses are different, and arguably, in trying to come up with an assured and alternate and available PNT solution, I would argue diversity is a good thing because of the fact that, because it's different, it's going to enable you to do different things, and it's also going to make you vulnerable to different ways. Next chart. So this one talks a little bit about how we do PN, and what we're doing there is, as part of our patented direct-to-cell technology that allows existing phones that are 10 years old to work with our satellites, we need to compensate for the fact that we're not a stationary cell tower within tens of kilometers of where you're located. In order to do that, we actively process the signals coming from the device to determine distance and to determine Doppler offset. In doing that, when you co-plot those, as you see in one of the little figures on the bottom, you can geolocate the device. That knowledge is available on the spacecraft. It can be sent back to the device that tried to talk to the satellite as a cell tower. It can be sent to a command post. It can create situational awareness. It can do a lot of different things. And so we've been doing this for years. We've not only located blue force, if you will, we've also located red force. And we've tested that in some different places around the world. Next chart, please. The next chart deals with the time element of this. I spoke about this yesterday as a sort of a tribute to Bill and his team here and the SLAM meetings. We were introduced to APL. They had a unique and well-developed twist technology, time transfer via satellite, and wanted to see if that could migrate to LEO. Previously, it was a technique that had been proved out very well in a GEO format, but LEO poses some strengths and weaknesses, opportunities and struggles. One of them is the fact that you're moving fast and you're also much closer. So the closeness gives you tens of dB of improvement in the signal strength. You'll hear that from others who are working at LEO. But it also means that you've got tremendous variability in the path length. Twist is a technology that makes all those things not matter because you're doing two-way transfers, and there are ways also to do one-way transfers. There's a little photo there of one potential CONOP, but there are many others depending upon whether the recipient of time is on a big platform or moving around. And what we have demonstrated in space is roughly 1 nanosecond accuracy to traceable time standards such as USNO or NIST. So, and you see there that little curve on the bottom is how it locked up in about 10 seconds and maintained that accuracy throughout the duration of the pass. With that, I will turn it over back to you.
Thanks very much. I'm Jeff Hebert. I'm from the Air Force. I appreciate the Navy inviting me here today. It's great to be back with the Navy. We've done a lot of cooperative work over the years between the Air Force and the Navy, and of course the heritage of GPS traces all the way back to the beginnings of the work the Navy did on satellite navigation. In my role in the Air Force, I'm basically the senior technical authority for PNT for the Air Force and the Space Force. I sit at Air Force Research Laboratory, but I basically provide advice, assistance to the entirety of the Department of the Air Force. I curate and manage a portfolio of science and technology that's applied towards PNT, and basically assist in facilitating that, getting that into the field. I think where AFRL and the Air Force has succeeded in many ways has been in the evolution of PNT from I would say a very GPS-centric point of view to something that's more open to alternatives today. However, I think where we are struggling greatly and hoping actually to learn a lot from the Navy is how to better integrate new technologies into our systems and maintain and sustain them over time. So I would say that's something that we definitely need to improve upon in the Navy. I'm sorry, in the Air Force, and we're looking actually to the Navy for some examples as to how they've done it in terms of managing their technical baseline for PNT. With that, I'll close and look forward to the conversation today.
Thanks, sir. Appreciate that. Michael, over to you. Again, stepping in as a relief pitcher. Appreciate you being up here.
Hello, everyone. I am not Karen Van Dyke, if people didn't put that together. So I'm going to talk from a DoD perspective, DON, and not the Department of Transportation. So I'm the Assistant Program Manager for Engineering for Assured PNT at PMWA 170, the Navy's GPS and Satellite Communications Program Office. I really do wish they'd give me a shorter title sometimes. Primarily, what my organization does is supporting assured positioning, navigation, and timing on Navy platforms, mainly surface ships and naval aviation, but we work across the Navy to try to ensure that everyone has assured PNT on their platform. Don't have slides, why don't we get into the questions?
Okay. Thank you all. We've got a great list of questions here. Michael, you didn't get to see them, maybe get to read them, but I'm gonna jump right into this question, and I think Dr. Hebert mentioned it earlier. He kind of hit on it when he gave his intro. But I'm going to start with the government. Michael or Jeff, you can ask this question or answer it away. What has the government done right or wrong with respect to A2PNT and PNT's roadmap, up to date, and what are your recommendations, your perspectives on what we should do right moving forward?
So what I think the government has done right is they have an understanding of what has led to difficult modernizations in the past, and that is closed interfaces. So they really are pushing for modular open system approaches whenever possible so that we're quickly able to bring in PNT providers in and out. So the work being done for the non-geostationary satellite terminal that my colleague Bill Jew works on to try to allow different constellations into the Navy's architecture easily is great, and then within Navy systems, they are setting up defined interfaces. So if you want to provide PNT to Navy surface ships or naval aviation, you gotta support this interface, and you're good. From our end, it will be easy. What I've seen that hasn't worked too well is that there is a lot of S&T money that has gone around without a clear path to program of record. And I really think there needs to be earlier engagement with resource sponsors across the DoD so that they buy in to the technologies that we want to transfer earlier, instead of program office going and asking for research and development money, a couple years down the line, find out if the sponsor would be willing to support it early on so we don't lose valuable technologies to the valley of death.
That's a great answer. Thanks, Dr. Hibbert.
That's a really interesting question, and I think for me, it's really easy to focus on the negatives. It's hard to, benefits are so upfront and obvious, you sort of look past them a lot of times, the things we do well. I mean, just the fact that we provide a reliable signal from space that can geolocate any of us to within, sub-meter accuracy, 24/7, 365, all weather. The miracle that is GPS, satellite navigation in itself, it's really hard to comprehend how impactful that is. Really, it's like a wonder of the world, and the closest thing I could say analogy to is like the internet. So like we invented the internet as a species, invented global navigation as a species. And but then you think about like, well, what's wrong with the internet? There's a lot of negatives to the internet, right? Social media impacts. So what are the negatives about GPS? Well, GPS led us to shrink our navigation systems in size, weight, and power to the point where we kind of broke systems engineering discipline. We have put PNT on air vehicles and other vehicles where it simply doesn't belong. It's dangerous, right? So you think about a lot of the drones we have. They have no business operating in a flight safety point of view with a signal that could be so easily jammed or spoofed, but we do it. That's a negative consequence. Another negative consequence the Air Force did because we're reckless, that the Navy will never do, is that we eliminated the navigator career field. There are no navigators in the Air Force. They don't exist anymore. That is probably incomprehensible to a naval tradition. The word Navy and navigate share common words. Like it's the etymology of that, right? Navy is a fleet of ships. Navigation is like driving the ship. That's what navigation is, right? And so we are so cavalier in the Air Force to have actually eliminated the career field. So as a word of caution, as we embrace AI and we automate everything and we rely on the computer to do it, the embedded GPS INS can't go to a meeting, pound the table and say, these are my warfighter requirements, right? So when you automate warfighting, right, you have to remember that people who are there to actually advocate for, fight for, and defend PNT in the budget. So, I could go on. I've got a long list of things where, but I don't want to be like completely negative on this. The other thing I think, to turn it back to a positive, if you work in the PNT community, you will not find a more tenacious, hardworking, dedicated group of humans I've ever been privileged to work around. And it really comes back to what is at the core of what it means to navigate. And, at the end of this conference, all of us are going to go home, right? And you're going to navigate your way home. And that feeling you get when you step over the threshold of your house, right? For that moment where you feel like you're safe, right? And you're content and feel that sense of joy. That is what humans have done and suffered through for centuries. It's imbued in us. That's what navigation is. So I guess where I'll end with that is that despite all of the challenges we have, just innate in us that we'll persevere in this, despite the fact that we've kind of
That's a great perspective. And don't worry, the Navy went ahead and got rid of celestial navigation. in its
But you brought it
academies.
back.
But we brought it back to the chagrin of everybody who has to take it. So it's a good skill to
good
have now.
culture.
We kind of saw that on the horizon as needed to be brought back into the curriculum. So that's a government perspective, and thank you. And I also have my views on it. But Dr. Joe, what do you think from a complete industry perspective? What do you think we've done wrong, and what do you think we're doing right, and what should we do moving forward?
Well, that's a great opportunity to say a bunch of things. First, let me also, maybe to start out, something that I think you're trying to do right, but haven't necessarily done right yet. So PNT, I think, as I said, mostly because we're different in how we approach it, and there are others, who have different approaches in the country other than sort of GPS variants, whether it's signals of opportunity or their own constellations or whatever. It is difficult to propose something that is radically different than that and have people get it. And invariably, all the risks that people worried about that make assured PNT something people kind of take for granted. The FAA, we fly planes with it, we do all sorts of things with it. If you have something where the phenomenology is not as well understood for decades, it's hard to have people have confidence in it, even if it works. It just hasn't been socialized. It hasn't been understood well enough. And I find that sometimes when I introduce this to somebody, who's new to it in the government, even if they're working PNT a lot, all they think about is, well, but it's different this way, and it doesn't work, and it doesn't do this, and it doesn't do that. And you sort of have to explain, well, yeah, but, here's where it does work, or here's where that can be improved to meet government needs instead of necessarily commercial needs. So I think that's difficult. I think the other thing that I think was part of a Space Force initiative, I think maybe it's Air Force Space Force, is to develop a test bed so that, I think all of us, especially when you're doing something new, you like the idea of a really good, high-quality test bed so you can see in a simulated real-world environment that it works and that it's reliable and I think that as the requirements, and there are going to be tiered requirements, as those mature, having not only a spec, but a way to validate that you're meeting it, that you're doing what needs to be done, that your improvements are working. I think that's an important element of it too. And I think the final piece, and it won't take as long to talk about, is that P and T are really all different, and they're kind of glued together with GPS, but that doesn't mean they have to be, and that doesn't mean the requirements, whether it's for resilience or other specifications, needs to be the same for all three for every application. So back to you.
Thanks, Dr. Joe. Appreciate that. Good answers all. I would concur with everything you've said. I still think as a force, as a DoD, we are still struggling to make sure that we are limiting those seams between our PNT discussions and our pathways and our roadway ahead. I think PNT is almost ubiquitous with all the warfighting disciplines, and the irony is it's probably one of the ones we could actually single up on the most when it comes to those types of disciplines. And I do know that the PNT Oversight Council has the highest level of attention in the DoD, which was almost unfortunate if you think about it. We have to be at that level to kind of answer some questions amongst the services. But it's also good in the fact that everyone is acknowledging that PNT and all PNT is critical for us to win the fight. With that said, I'm curious. We've been talking the last couple of days about all this capability that's being delivered to space. We've been talking about the just change in the paradigm of, like, you don't need to have a satellite dish and 2 tons of equipment on a ship in order to move data across the globe. Now we're getting to the fact where you have cell phone towers in space. So talked a little bit yesterday about there's going to be essentially a flood of Internet of Things capabilities not just civilian-wise, but military-wise. And we're going to see this happen, well, I don't want to use the term overnight, but within the next couple of years, unless you tell me I'm wrong, everyone's going to be able to access space with their cell phone, if they're not already doing it today. Thinking about that and the flood of the capabilities that might be accessible by the military, what are your concerns, or what do you view as risks or threats to the fact that now all of a sudden everybody's got a handheld something that requires PNT? Well, we used to have individual daggers and PNT devices, that were certified, but now we might have to be leaning on commercial or whatever they have in their hand in order to execute mission. Do you view that as a risk? Do you have any thoughts on that? But what would be your take on on your concerns with PNT with respect to all of a sudden the flood of those capabilities in the hands of soldiers, sailors, airmen, whatnot? I'll start with Dr. Joe.
Okay, so of course we all know the things we worry about we fix. They never happen. They're never bad. The things we don't worry about are the things that bite us. I think that there are probably a place that maybe we don't look enough is spectrum. There's a lot, all of these things, at least that are RF, maybe Earth's magnetic field examples, and, these things that look at environmental characteristics, maybe they don't have those problems, but pretty much everything that relies on RF one way or another, we're operating in spectrum, and that spectrum is going to be a battle space. It's going to be contested, and it's going to be contested commercially, because there are fights that go on every day in our own country, between FCC and NTIA about, well, who should have that and who should have that, and when are the filters good enough, and how are we going to displace this for the greater good of everybody? What are we going to do in wartime when we need spectrum that may be used by others, maybe even adversaries? So, it's not only jamming. So I think that there's a lot of thought that needs to go into that, and how we migrate through what is a commercial underpinning that in all aspects of PNT, and how does that transition into a contested space? So I think that's one thing that's pretty important. I think there's a networking piece of this. Too often people, especially smaller companies, think in terms of being a component of a bigger piece. And so I think it's important for us and for all of us to say, okay, we're a component of a system. How does that integrate with other components of the system, whether it's for situational awareness, or whether it's for interoperability, or whether it's for assurance? How do you sort of calm and filter all these different time or position, location information? How do you achieve resiliency through that, in addition to just resiliency through our own proliferation of our LEO system? So maybe I'll just stop there. I think those are a couple.
Thanks. The gentleman on the left.
Yeah, so I'm a big believer that the convergence of communications and PNT is not only inevitable, but we have to drive it to a place where it's effective and enables a lethality for our warfighters. History tells us that the warfighter is going to use whatever tool that they have at their disposal. There's just you cannot prevent or stop the acquisition of those tools. We can try to shape it, but they're just going to bring whatever they've got into the game. And they're going to operate with it, and we've seen that time and time again. So while our policy says GPS is the primary source of navigation and we will use military encrypted GPS receivers, we know that our warfighters use many other non-approved devices and will continue to do so. What I think we need to enable, and I think Michael talked about it in his briefing, is that we need a system in our PNT architecture that allows us to rapidly onboard the best capabilities that America has to deliver when it needs it. And that's because alternative PNT capabilities need to be tailored to the platform, tailored to the mission that platform is performing, and to the environment it's performing it in. So, in my case, an aircraft that's doing let's say an F-16 doing close air support in the desert requires a certain PNT configuration. That'd be very different than that same F-16 doing, you know, defensive counter air, let's say over the ocean, right? So we need the ability to plug and play PNT sensors, almost like we load out, you know, new weapons capabilities on aircraft, right? We have, you know, standard pylons, and we have communications interfaces, and we have the ability to, you know, optimize that weapons loadout, and we need to optimize the PNT loadout to fit that mission, platform, and environment. We're not going to get there overnight, but open architecture, software-enabled, driving as much as we can into software so that we can rapidly reprogram those capabilities, and then defining those interfaces, I think, is what's needed. And that is going to be the difference, I think, between whether, you know, we win or lose in PNT coming in the next decade.
I can't agree more with what Dr. Herbert just laid out, especially with the warfighter is going to use what they think will be helpful, no matter what we write in policy, no matter what we say. They're bringing it on. So my concern is that sources of positioning, navigation, and timing will be brought on that aren't properly tested, aren't properly integrated, and potentially put the warfighter at risk either of being spoofed, of suddenly losing that information, or of giving away the position of a platform if that PNT is developed from two-way communications rather than one-way, such as by GPS. So really, to get around that, I think one, we do need the open interfaces to bring stuff in, and we need to provide the PNTs that the warfighter needs so they don't feel like they need to go off on their own and grab a GPS off the shelf or grab you know, something that is going to do direct to cell to a determined position that way. So we really just need to give them the tools that they need to do their jobs so they don't feel the need to supplement.
Yeah, I think those are all great, obviously great answers. It brings to mind or a memory for me when I and many others were stationed over in Baghdad and Afghanistan, and the biggest threat to our troops were radio-controlled IEDs. And we were sent to deliver essentially a wartime acquisition program of record solution to defeat, lack of a better term, to jam the signal such the ID wouldn't blow up and the troops could move on. What I found, which was really unnerving, was there was a lot of folks out there trying to figure out a different solution. And what I realized, if you handed a warfighter a capability, and you told them that it would work and keep them from getting blown up by an IED, the worst thing, they would believe you. And that really worried me, because if you didn't have a tested out solution, they would change their TTPs because they were doing so much at the same time. That was one less thing they had to worry about. And that was very it was very eye-opening for me as somebody who was doing wartime acquisition, is you have to hand the warfighter a capability that they know will work in the hardest and the most difficult of times. And if it doesn't, just let them know. They will figure out how to TTP around it. But again, I think PNT is almost on that kind of like criticality with respect to how we fight. You know, if they believe that they are where they are and the time is what it is, they'll go win. But if it's not what it is, they'll find another way to figure it out. We just got to make sure that we're delivering that capability, that we can give them assurances that it will work. So thanks for letting me have that little bit of a diatribe there. That being said, another question, I appreciate this question from Bill, is, and I'll start with, Michael did a great job of defining this, and I'll have some folks who are not in your brief, but how would you define assured and alternate PNT? And how would you like to see it realized or utilized in the hands of the warfighter, Michael?
So for anyone who didn't get the technical definition written out in my brief, I'll do my best to paraphrase off memory. So assured PNT is really that the warfighter gets the information that they need. The PNT data needs to be checked for integrity. It needs to have the right level of accuracy, needs to have the right level of availability and reliability for them to perform their mission. And alternate PNT is connected to that, because that's the supplement to GPS that lets warfighters achieve assured PNT. Sorry, what was the...
How would you like to see those type of capabilities utilized or rolled out into the hands of the warfighter or into the platforms?
So The way I'd like to see it rolled out is as a supplement to what we have now. So, for aviation, for submarines, for ships, primarily you have GNSS and you have inertial navigation systems powered from IMUs and gyroscopes. We need more sensors, we need more data fusion. We just need to bring in more systems to that PNT architecture, and we need to make it transparent to all of the PNT consuming systems. So if there's a radio that needs time, if there's a charting system that needs navigation information, if there's an antenna that needs to know what way the ship is pointing, I don't want them to have to think about where their PNT is coming from. They shouldn't have any need to know. It should all be taken care of in the PNT system, and we need to be able to quickly bring in that PNT information through an open architecture so we can slot in new technologies as they're developed without a major modernization.
Yeah, thanks. So I think what Michael provided is definitely the right answer, the textbook answer. It's the answer that you should definitely take forward. I'm going to give you an opinion, which is my opinion, and just to, I guess provide a little bit of drama, nothing else, right? So I don't like the term assured PNT at all. I feel like it's what we want the warfighter to have from like a policy standpoint, but may not be what they need. And so, I'm just not a fan of the word. And it's just because it's a word. But the definition that Michael provided in terms of the attributes, yeah, that's what they need. I just don't like calling it assured. In the Air Force PNT strategy, we write, the words robust and resilient. I'm not saying that those are great words, but those are the two words we use. And so just to provide some additional color, I guess, I can describe how we, colloquially use those words. Robustness, we think about, again, colloquially, like Rocky Balboa, right? So think of, this person that just gets pounded, constantly is kind of doing the rope-a-dope strategy a little too much, and that's what we have with GPS, right? We're just making a bigger, badder satellite, more power, and we are going to basically keep taking it on the chin and not fall down. And that's robustness, right? So PNT systems need to be able to take a punch and be able to survive, that first punch and last through several others. But knowing that a dedicated adversary, if GPS is seen as our center of gravity, they're going to take it down. And so if we do get knocked down, we have to figure out a way to get back up and fight another way. So the analogy there is more like the Karate Kid, right? Like no one probably ever thinks I want to be a scrawny, right, high schooler. No offense. But again, this is, just trying to be spicy here. But when the Karate Kid in the movie, right, the adversary sweeps the leg, right? That's like a completely uncalled for move, right? Like against the rules, just like spoofing or anything else, right? It's like not gentlemanly in terms of the art of war, right? But it's happened, so you have to go into crane stance, right? And then you apparently the adversary leads with his face, and you kick him in the face, right? So that's how that movie played out. So robustness and resilience, the combination of the two, is kind of what we have in the Air Force PNT strategy, and terms that I approve of. And I have a struggle with the word assured, just because I feel like it's something it's just a word I don't particularly. As far as alternative goes, I think what's really interesting is that we came up with the other term, which is complementary PNT, and because we didn't like the word alternative. And one of the reasons why we didn't like the word alternative is, and I'm fine with alternative, is that we felt like it was something where it could replace GPS. And so the group of folks that are going to fall on the sword about, we must always have GPS, right? It's written into our policy. GPS is a primary source of PNT, right? I disagree with that as well. I don't think it needs to be the primary source. The primary source of PNT, right, is your clock. That's where it all begins. And then from there, you have an inertial measurement system. And from there, you have possibly a barometric altimeter or some altimetry. those things drift and they have biases and they don't stay, they are unconstrained, right? And so you need complementary sources to correct the drifts and the biases. And of those complementary sources, one of the best ones is GPS, right? And then everything else is an alternate. So that is my definition, but just one person, again, don't speak for anybody but myself here at the table right now. So yeah, with that, those are some sort of, I guess you could say, contrarian, off the wall, just trying to spice things up. And again, no offense, Michael.
Well, to spice things up, I think we're going to now refer to you as Dr. Jeff, Mr. Miyagi Hibbert. You okay with that?
I don't know if I'm okay with that, but
Fair enough.
I've had worse call signs.
There it is. Thank you.
Yeah.
Over to you, Dr. Brovman.
So I guess where I'll start, you did that very eloquently. I have a personal campaign against adjectives. I think adjectives are bad. They just mean different things. And, how much pain are you in? Well, let's see, how do I define that?
8.
So,
Stay
so I'll let that go because I think you did it very eloquently, but that is a problem. I think the other thing that we recognize, especially those of us who have an engineering background, is engineers solve problems. So give us a problem set, give us a little bit of time, a little bit of resources, we'll come up with answers. In effect, making something that maybe has a commercial purpose as well, like what a lot of the alternate PNT things are that industry is doing. We're not doing it solely for the government. But there's a part of that problem set that doesn't exist unless you give it to us. And it's solvable. There's this standard that cellular devices adhere to called 3GPP. It's a committee that set up a bunch of standards. Those standards never contemplated cell towers moving at all. It never contemplated cell towers having to work over distances beyond line of sight. You don't design a system that has features that nobody cares about, nobody wants, nobody intends to use. So all that stuff was not part of the standards. We essentially cheated. We broke the codes. We came up with ways to leave those standards in place, don't mess with devices that are out there already, and still make the system work. That's going to happen here too. There are vulnerabilities that every one of these alternatives has. And you can't stop there. You can't say just because, it does this or that, just because it's only good to 10 kilometers today or whatever it is, or 100 meters today, that it has to stay that way. But it's only going to change in response to your requirements, your needs, and in many cases, your money to build something into it that isn't necessary for commercial. So I think that's important to recognize and make sure we do that. The other thing is GPS has been around for 50 years. And it's hard to, unless you live through those early years, that first decade, it's hard to imagine how rough a road it was back then. Now, so many things have been improved and worked through, and it is what it is, and it's amazing what it is. And all these alternates are going to have to go through that too. And if we're smart, it won't take 50 years to do it. But it's not going to be a year. It's not going to be 2 years. But there are things we can do that quickly. We could put up a twist time capability on a global basis probably in a year and a half if we really wanted to. So I think that we just have to keep that perspective, and we also have to keep the perspective of, I personally don't believe in one size fits all. Okay, it's sure not true here. There are aircraft needs, there are ship needs, there are dismounted needs. There's a lot of different needs in terms of your mission, but also in terms of, how good is good. And we have to stop thinking about it's got to be one thing. The beauty of alt, meaning whatever you want it to mean, is that there can be alternatives, and they don't have to fit everything, and there can be hybrid solutions. So I think, it's both something we have to worry about, something we have to open our minds to, but it also means there's a lot of solution space.
That's a great answer. All of them, they were fantastic answers. Thank you. I appreciate that perspective. We only have a few more minutes left for the panel, so I just wonder if there's anybody who might want to ask a question to the panel before we move into their final statements.
All right, great. I don't want to get into adjective soup, but I almost had the captain convinced that A2PNT was correct now. I have to put a C somewhere in there. So I think one of the questions that we try to pursue was is basically human flight, and GPS is the only one approved by FAA. Do you ever see a day when we may allow something else, something that's more complementary, alternative, whatever it might be, that may allow us to go without GPS? I'm not suggesting that we should go away from GPS, but do you think FAA may allow another system to be an alternative, not necessarily complement?
Yeah, I wish Karen was here because she could speak well about this. But, we do have TACAN, we do have means of navigating without GPS. So I think the answer is yes, we do it. Yes, we will find a way to trust other sources. It will take time, as our other co-panelists mentioned here. You have to remember when we built the case for GPS to do like en route and precision navigation and GPS-aided landings, there was a large body of science about how we could build the integrity and trust, and we defined what those metrics were, and they traced back to the probability of an accident, right? And so that hard work would need to still be done, but I think it is definitely possible, doable with any other form of PNT. We just have to put in the work.
The one thing I would plug for anyone thinking about potentially producing anti-jam antennas for the DoD is the controlled reception pattern antennas, the SERPAs, that are used across the DoD as of September 2025 are going to be taken off the ITAR list. So your potential customers are going to go from, maybe tens of thousands if you're including munitions, to every single drone and aircraft used in the civilian world, plus any other critical infrastructure that doesn't want to get jammed out. So your customer base can massively expand, and hopefully with that economy of scale, you'll be able to bring down prices and benefit everyone. So referring specifically to the question, I think that FAA is definitely sticking with GPS primarily, and GPS is going to be a lot more resilient for commercial aviation once they get anti-jam antennas integrated.
Actually, I didn't realize that SERPAs are going to be taken off the ITAR list. That's fantastic, because I was the program manager for Magna, multi-platform anti-jam GPS navigation antenna, mouthful there. That's a SERPA antenna array, and we tried to release that at least to our allies, and we struggled. So that's fantastic news.
Did you want to say anything?
Yeah, I always want to say something. I think one thing that can help is that as we have ways to cross-check GPS, so for example, time, if one of the things GPS produces is a time solution, if we have, say, twist or something that provides an alternative time, now you can cross-check that. So you're still using GPS, but you've got a way to, if it's being spoofed or if it's failed or if there's a problem, you've got a way to cross-check. And over time, those cross-checks build a fabric that could completely replace GPS if you needed it to. I think part of the challenge that commercial has is that we're trying to sell something that to a lot of customers, they can get it free. And so if GPS is free, there's not really a lot of money, except when suddenly they wake up and realize that the banking system has failed, or all the cell towers don't work, or something else happens because, somebody has messed with GPS. So I think some of these things unfortunately take time. The Navy and DOD does not have that luxury of time. So you've got to prime the pump, you've got to push it, because if you wait for the banks to wake up, you know, that's too long.
Okay, actually, I think you made a case for complementary, so I'm gonna start saying CAPNT. So, Dr. Hebert, you win.
We're gonna make a better acronym than that, Bill. Just give me a few minutes.
We'll figure something out. Someday we're gonna be going to the moon, and Elon Musk will take us to Mars. How will you do PNT? What does PNT look like in the future? I'm really pointing it to Dr. Hebert. He's a futurist person. How will we provide PNT for interplanetary missions?
Sure. Well, I mean, first off, NASA's doing a bit of work in this area. And so there's really good people thinking about this. DoD is supporting NASA in their endeavors. I think what we can definitely say is that it's hard to imagine PNT in the expanse of space without it being very tightly coupled to communications and the communications architecture. And when we couple communications and PNT together, I think we have to make sure that we find ways to make comms and PNT mutually reinforcing, and that we don't add common vulnerabilities. So, for instance, communications requires often an antenna to be pointed in a certain direction precisely, so there's a dependence on PNT. And then PNT requires communications for like timing, synchronization, encryption, you know, the data we need for assurance or trust, integrity of other signals. So just like we fused inertial navigation and GPS together, and both of those aided each other and made them stronger, we've got to figure out the things about communications and PNT where they gain that common strength and don't impose those mutual vulnerabilities. So you know, that's I think what I see for the how we're going to get out to space. And I think the last thing I would say is that we need a challenge problem for PNT in space that motivates and inspires the industrial base a bit more than what we currently have. So I think what I'm seeing is a evolutionary approach to PNT in space, and unfortunately, we don't really, well, okay, so there is one challenge problem that I think is potentially motivating, and that's human spaceflight recovery. So when we eventually have hundreds and thousands of humans living and working in space, there's going to be times where we need to go and recover or retrieve or support those humans. And that's going to require PNT capabilities that we don't currently have, in my opinion. You think about you know, finding someone on the surface of the moon. That's a very daunting challenge given the lighting conditions and the terrain. And so we're going to really need some innovative PNT capabilities that go beyond what we have currently on the books. And so I would like to throw that out there as a challenge to try to figure out how to do human spaceflight recovery better with PNT.
Okay, well, I think that's our time. I want to bring it a little bit home. Bill had me up in Redmond, Washington last week on Thursday, and I live in Northern Virginia. My wife's currently in Colorado taking care of her parents, so she likes to track me on her iPhone, you know, say, hey, where are you at today? She didn't understand, and she took a screenshot of it. She goes, why are you in Taiwan? I said, what? She sent me a picture. I was in Taiwan on my iPhone to her iPhone. So, oh no, how do you explain to your wife that you're in Taiwan, you really aren't in Washington State, right? Because she believed, you know, she didn't believe I was in Taiwan. But to me, I thought that was a very interesting thing that happened. She goes, you kept jumping from Washington to Taiwan, back and forth. So if that's happening here upstate, you know, Washington, you know, as we understand, it's not just a wartime concern. A lot of this will be hitting our civilian sectors as well, that we have complementary, assured, alternative, and cool PNT. So I'm throwing cool too for Dr. Ebert. Anyway, I want to thank so much the panel for showing up today, and especially Michael for stepping in here at the last minute. So can we please give them a quick round of applause? All right, and I believe this room is going to be turned over. They're going to start, I think Brian Lopez and the team are going to be working and focusing on 5G for the next day and a half. So please stay and attend. It is fantastic technology as well. Thanks, everyone, and have a wonderful rest of your week. Yeah, brother. Oh, yeah, yeah, yeah.
We're going to kick off the next panel as quickly as possible so we can give them plenty of time to talk. So if we're going to go into some unmanned discussions, Captain Mel Yokoyama, retired, is here, and he has a team. So as soon as they get in place, then we'll give you a 5-minute bio break. I'm going to be like that. There you go. Recorded, and there are people remotely dialing. Oh, that's great. Not that I don't know you already. It's a good news story, man. Take about 5 minutes. Take a couple minutes. It's a good story. Yeah, you all set? Okay, everybody, thanks so much. We're going to kick off the next panel. mass producing modular UAVs on the front lines, and I asked Captain Mel Yokoyama to come and speak to us about this. He has direct experience in Albania, and Mel is a 30-year Navy captain, retired out of NAVIC PAC as the commanding officer there, and a great friend of mine from my aviation days working VQ. Thanks, Mel. Mel, I'm going to turn it over to you to let you do your introductions there. By the way, Mel's CEO today of his own company, Decisive Instincts, so please stop by and see him. It's a small business, 8A. Is that right? Do I have that right? Please say a few more words and introduce the guests. Thanks so much.
No, thanks, Brian. Thanks again for the opportunity. We were going to kind of switch up the talk here. So we were supposed to bring props, but we couldn't fit a 20-foot container in the space and start producing UAVs. But I think it's going to be a great panel because you have three, no kidding, non-traditional, or two, I'm just here talking, two non-traditional CEOs that are making a difference out in the, for DoD and other three-letter agencies. So my name's Mel. Last job was NAVIC Pacific, like Brian said. First 20 years flying, signals intelligence, ES3s, EP3s, and last job was commanding officer of NAVIC Pacific. So what I bring to the table is finding companies like these two incredible folks and trying to get their stuff out, not just to the acquisition community, but directly into the hands of our warfighters where it matters. So I'll turn it over to Gene, and Gene will turn it over to Dan.
Hi, my name's Gene. I'm CEO, co-founder of a company called Resecurity Inc. based out of Los Angeles. Dan?
My name is Dan Meiji, and I'm CEO and co-founder of Firestorm based out of San Diego.
So if you get an opportunity, look up their companies on Google, Firestorm Labs and RE Security. And then mine is, I'm a systems integrator, Super 8A, and one of those things. But I think what's important, that's what's different from us, and I see we talk to some government folks outside, is that we don't sell stuff. We try to solve a problem. In this specific case, the problem we're trying to solve is this tyranny of distance. We've all deployed. Most of us have deployed out to that theater. I spent a lot of time out in what Brian is saying, Albania, but most of my time was flying off the coast of China, South China Sea. So very familiar with that territory and what the challenges are. But I want to start with Dan about his company.
So what we do at Firestorm is pretty interesting. The idea started as a modular multi-mission drone because our vision is you should not buy one drone for each mission. You should buy literally one SKU and then put a bunch of different payloads or propulsion systems on it. That drives down costs. That improves reliability and manufacturability. But where we've been dragged in the last 2 years, kind of out of necessity when you look at that map, is to help solve the tyranny of distance. So we use industrial grade 3D printers, and we have a very special relationship with one of the largest OEMs in the world to build these drones. And what we've spent the last kind of year and a half doing is figuring out a way to put that in a container, like a 20-foot container, so you can move it anywhere in the world and within 24 hours start manufacturing at the edge. Where this will go over the next couple years is it won't just be building like a fleet of products that we're building right now. We're building a Group 1, a common launch tube variant, a Group 2, a Group 3, trying to kind of have like a suite of systems. But we also want to build other people's parts and other people's products in this manufacturing solution, right? The whole vision is if you can localize a supply chain and use a commonality of parts, we can build a lot of stuff at the edge where it's needed most. And so you're not having to figure out how do I get, 10,000 drones from Michigan out to Guam.
Perfect. And now what we want to really talk about too is that's the objective, is to get his capabilities out to the fleet, but we want to protect that supply chain. So Gene.
And I think part of the problem is especially in our industry, you hear a lot of marketing terms, AI, ML, supply chain, third party, fourth party. The reality is everybody's using the same data to give you pretty pictures. And what I always try to emphasize is, and I'm not here to market my company, the reality is that we need to be more cognizant of all the interconnecting parts. We keep naming these things like with some fancy words in marketing. The reality is that we need people, process and technology to monitor all of these components. If it's in Guam, I want to know the telecommunication. If it's being serviced at a certain port, I want to know the address. I want to know the people there. And we need to be able to collectively pull all this information. And I'm not talking about due diligence and somebody's checks, but also looking at whether or not these individuals or companies that you're working with has a material risk that would impact your organization, in this case, I guess, Department of Navy, or America in general. And it's important for people to understand, like, and I'd be the first one to apologize because we do a lot of marketing around the terminologies and the word. In reality, it's just all nothing means nothing. And I tell people it means nothing. When what we need is right people and right technologies to protect our warfighters and also give our warfighters the opportunity to pull information better, more efficient, and also be able to deliver on promise.
Yeah, one of the good things about these two companies, it's not PowerPoint deep. They're doing it today. I went to his warehouse. It's here in San Diego. It's actually expanding because of the amount of demand he's getting. But it's not in the fleet yet. So that's what I want to talk about. Air Force is all over it. Army is all over this. Because they see the capability and the demand is not producing stuff here, but producing stuff out there. Because when the balloon goes up and there's a conflict, the supply chain is not going to keep going. And so we learned that, I spent a lot of time in Iraq, of course, in Afghanistan, these places. During the Iraq war, the contractors left. They couldn't be there because it's on their contract. And so we're stuck with planes and material that just sat in the tarmac or in the warehouse that couldn't operate. And that's where we want to get this Dan's capability out to the fleet as fast as possible. So Dan, talk about how you adjust to the battlefield conditions with your UAVs.
Yeah, we think that there's a couple ways in which you're going to solve this problem. And I'll be honest, like, we've built a really interesting technology, but we're also figuring out how this will be implemented, right? And so we have kind of palletized our solution. So you can basically have our 20-foot containers go and be set up anywhere. You plug in some clean power and away you go. And then you have ISU 90s of kind of resupply that can follow you if you want to build our product. The next level for this, though, and we're already starting to do this in some places in the Pacific, is to start localizing the supply chain, right? What can we tie into that they have available that lets us stay in the fight? And I think that's going to be crucial if there ever is a conflict out there. I don't think we quite understand, and we're seeing this right now in the drone industry where China's like, well, we're not going to sell certain companies parts. That has dramatically affected our ability to build drones. And so you need to be resourceful and you need to be thinking worst case scenario at all time. And that is like, what do we have available to put on this thing so that we can get it into the air? I don't think we think enough about that, and we're trying to solve that from a manufacturing standpoint and from some of the hardware and software we've built that allows for rapid connections of other sensors, other propulsion methods, other compute or cameras onto our platform.
Yeah, I want to touch real quick because this is important, is adjusting to the battlefield conditions. So can you talk about the modularity?
Yeah, I mean, it goes back to kind of what I was saying in the beginning, right? Which is like, we don't think, I personally believe that like the companies that are selling one drone for each mission to the government are doing us all a disservice, as taxpayers. Like, our vision is that you should be able to get, 85 to 95% of the same type of like use, if you will, out of a multi-mission platform if you build it the right way. We don't buy a new cell phone for every app we're using, and that's the same approach we're taking to drones, right?
One more, reducing the cognitive load.
Yeah, so we spend a lot of time talking to the kill teams in Ukraine, the people who are actually doing this, right? I had a guy in my office last week who has blown up about 300 Russian tanks, okay? And I had the top fixed wing trainer in Ukraine. He's trained 5,000 pilots, okay? These kill teams are 20 people, all right? Let that sink in and think about what we're training our UAV operators to do. And more importantly, and this is where it gets kind of crazy, they are doing this all day long, okay? This is not like I'm going out to the field and I'm flying an FPV. This is their job, all right? And the concern that I have when I look at how we're doing a lot of these different things is it's fine if you don't want to specialize the UAV operators, but then you have to build the software to reduce the cognitive load, okay? So if you can automate it and make it easier for them to pick up and learn the system, that's how you reduce the need to be doing this all day long. But the cognitive load's a real issue, okay? These guys are working in 8 to 12-hour shifts, all right? And then they go home and sleep and they do it again. And so one of the things we're doing is we think there needs to be kind of a baseline of software with like some mission sets, if you will, that are built in so that somebody could rapidly be trained onto the system and can kind of push a couple buttons on our app or on our tablet, however you want to use it, to carry out a basic mission. Reducing the cognitive load for how many drones are going to be required is going to be crucial in the next fight. And it's something we're really heavily investing in from the lessons that are being kind of learned in Ukraine.
Perfect. And I want to switch it over to the software side, especially the digital thread. And I'll turn it over to Gene because once we get the products and the capabilities out in theater, now we have to protect it, not just physically, but virtually.
And I think, Dan has a great point about the load, right? When we talk about cyber attack supply chain, in itself, he's actually reducing that the blast radius from actually potential risk to all the components thereof. So by reducing those things, it actually reduces footprint for supply chain risk. But also when we look at whether it's IT or our equipments or our military apparatus, there are so many components, and especially in the technology world, we are buying extraordinary amounts of software with knowing that there is a monthly defect that need to be fixed. And these are kind of like an open door that happened, like a window that opens in your house like every month. And there's that point of opportunity. And the goal is to make sure that identification or the defect time to recovery or identification is key to ensuring that you're reducing your supply chain or defects. And most importantly, at the end of the day, I think we're talking about, I would say, a majority of the problems that we see in supply chain is never the technology. It's always going to be the individual. And it only takes one person. And, we talk about material risk or breach or compromise. I always tell people, it's like it only takes one person to kind of own the entire environment. And I think it's important to always understand, like even with the zero trust, very good terminology. If you look at the history, it's been around for 20 plus years. And we just put a nice word on it. But the reality is building that zero trust starts with you, human beings.
Perfect. And, I want to touch on one thing is something is at least definitely dear in my heart is delivery speed. We talk a lot about getting things out fast. Who's new to government contracting in here? Okay, so everyone's experienced the speed at which acquisition moves. The journey. And then now on top of that, you have all the other compliance rules, ATOs and CMMCs that's coming out, which is great. I mean, that's critical because we need to protect, we're talking cyber when it comes to compliance. But at the end of the day, it's the warfighters out there, the warriors on the front lines that are waiting for stuff from the United States to defeat the enemy. We need them to concentrate on fighting the fight, not fighting their equipment. And so this is where I talk about cognitive load. It should be very simple, and you have to engineer speed into your products, which is what Dan Maggie did with his company and what Gene did with his company. We want the corporals, the sergeants, the second-class petty officers out there, the E5s and O3s. They don't have to think about how to operate this. It's intuitive. Just hit a button, it works. Same thing. I mean, today, as you know, for the folks that do government contracting, we have reams of paperwork of requirements. Hoping that will change soon. If not, we're falling behind. China is already has an order for 2026 of delivering, of actually delivering and having that capability of 1 million combat drones, not just your hobbyist drones, 1 million of it, combat drones. That's scary if you're not, of course, tracking the swarms and what they're doing out there. So let's talk about, I want to get back to the supply chain because I think that's critical for this audience on the IT side. So can we, so Gene, if you could talk about, I don't know, like how do you protect your current Fortune 500 companies? He's also protecting other companies, not just government.
So, you know, Microsoft is one of our, is anybody from Microsoft, just in case? Okay, good. Microsoft is one of our clients, and we monitor their tier 1 suppliers. And what that means is their most critical suppliers that provide delivery and operation of Microsoft Azure environment. So these are data centers around the world. So you've seen a lot of tools. CMMC says it, like there's all these solutions that do third-party risk management and supply chain monitoring with pretty pictures. And you'll see the security rating or security scorecard. The problem is those are just open source information that tells you like, oh, it's good or bad, like finding stuff. What we are doing and what we do for not only for Microsoft, but even for national defense. So we have clients in Gulf, South America, Central America, where they use our solution for national defense. And what we do is we don't just give you the cyber stuff, like the vulnerabilities, the dark web, all this OSINT stuff. What we actually do is we commit to having human intelligence operators actually engaging the adversary, engaging on those very specific things. Because the reality is there's a lot of criminals, and they don't, I think people have a misconception of how they work, but they work in sectors, energy, government, military, and we have to develop those relationships. And we need to understand what they're doing, how they're doing it. So we have to stay persistent in their environment and to collect that information. So combining the human intelligence and the signal helps us to understand, A, whether or not our client supplier is being targeted, and whether or not they have a material breach that would create a material risk to our client. That is not something that can be done with the technology. That is workforce. It's kind of like cognitive. We have to understand that missiles don't fly by, planes don't fly by itself. I know the UAV, but I get the picture. But the reality is that everything is going to happen with human touch. And if you don't have that combination of solutioning, then you're just relying on technology.
Yeah, for zero trust is not access control. It's
Correct.
much larger than that. And that's where the whole ecosystem of the supply chain is important, from the human level to the dark web.
And I always tell people, it's like, look, if don't invest on technology, invest on people first. If you train and invest on the people first and do it right, all of these technology integration deployment will be done quicker, faster. Even, these outside of the integrators, there are a lot of technologies that are very, very complex. But I would say 80% of the technology that we use today should be deployed within a month period. And if it requires a training, you don't have the right software, because that means another time to operate. And all of these components become a supply chain issue and your risk, because you have an operator that doesn't know how to use the platform, and you have a time to manage and administer the platform. All the while, these things are actually operating in a production environment, so you're actually creating more risk for yourself than anything else.
Hey, Dan, you want to tag on with that from your perspective?
I think supply chain's complicated. I mean, if I was China, I'd be in there right now trying to disrupt, assuming there's going to be some sort of conflict, as much of it as I can. And so having software that can help, track stuff and keep it safe, I think is really important. I also just think it speaks to the need to have kind of the entire industrial base in the US start to get spun up. If you guys have read the book Freedom's Forge, where it talks about building all of the industrial might that really helped the world win World War II, it started 4 years before it really got to peak manufacturing capacity. So in 1938 and 39, before they're even in the war, they're spinning up the industrial base. And it was not just like General Motors or Lockheed doing this. It was thousands and thousands of small businesses, right? And so if we're going to be resilient, we have to start thinking in that way. And it means that you're going to have to kind of have an understanding of what you need from a number standpoint. And then you're going to have to find a lot of different people to help you get to where you need to go. All that being said, in the face of, you know, Chinese cyber attack capabilities, which, as we've watched for the last 20 years, are incredible at getting into places and disrupting things. So it is a complex problem. And so I think we need to kind of be nuanced in how we think about how we're going to solve it.
Yeah, I want to bring in now from a business perspective, cost. So I spoke to, he's not here, Commander Shui. So he used to be with me in Japan, but he just got off the USS Eisenhower, the Ike, and if you're tracking them, they're in the Red Sea shooting down drones. And he was a combat systems officer on it. So I said, what is your biggest challenge out there? If you're familiar with the vertical launch system, VLS, they had to rearm that thing more than once, and you're talking billions of dollars shooting down basically drones made of wood that are maybe $1,000 bucks. So your return on investment, we need to reshape that. And so when it comes to cost, I think this is a good option. The enemy's figured it out. And so going back to Dan about cost, how are you keeping your production costs to the government price point?
Yeah, I mean, let's talk about air-to-air counter UAS. This is like one of the hardest problems we face across the DoD. My first company was an RF-based counter UAS company. It's called Citadel. We ended up selling it to Blue Halo about 35, 40 days before we became a SOCOM program of record. That was 10 years ago when we started that business. It is a completely different ballgame now, okay? We're not fighting ISIS using DJI drones. You have, China, Iran, Russia, and now North Korea sharing best practices, okay? Changing how their communication links work. The Ukrainians are telling us every 3 weeks they basically are modifying their control links in a way in which they have to almost re-engineer their RF-based attacks, okay? So that's kind of on like the digital side of things. But now to get to Mel's point, like air-to-air, which is like the new hotness, the budget numbers are insane. What we really need to do, in my opinion, is, okay, let's take a step back. Counter UAS 1, I think when we ended up, Naval Special Warfare was our first customer, okay? They told us they had deployed almost $2 billion of prime solutions. They basically took IED systems, flipped them upside down, and tried to blast drones in the sky, okay? It didn't work. They Googled counter UAS companies, and they started bringing in small companies. I think that's probably where we're going to end up just because of the production, like, we'll call it deficiencies we're facing. I think we need to really figure out if this is the solution we're going to use, and it's going to have to be a mixture of either air-to-air, radar. The Ukrainians have built an incredible network where they have cell phones on 40,000 posts that they listen to the sound of a Shahed coming in and they can triangulate where it's coming from. That's a low-cost solution, right? But it's that type of thinking, not just like hit the easy button, we'll give it to a prime, and we're going to then get a solution in 5 years. The fight is going to be way past where we are, and we're not going to be able to resupply, like you're talking about, these exquisite systems that are being used to shoot down drones. Do I have an answer for everyone here today? No, but I think we should be de-risking this by bringing in dozens of smaller companies that are trying to solve this problem in unique ways so that we have a hedge in case we can only make 200 of these anti-drone systems a year, or our production line gets delayed for whatever reason and we're in 28 and we haven't resupplied what we need for these systems, right? So think about what Mel just said. China has ordered 1 million attack kamikaze drones, 1 million. How are we going to shoot them down? How are we going to stop them, right? Maybe the AI in them doesn't work today, but that's where the puck is going, okay? The puck is going to no radio link. It's going to be, here's your kill box. Here are the images you're going to match on your algorithm on your camera for automatic target recognition. Go run into whatever you see. How do we stop that? I don't have the answer today, but I think it's really important for us to be thinking about bringing in non-traditional folks to help solve that problem.
Perfect. Go
Uh,
ahead, Ryan.
Just tagging on that, has anybody seen the Olympics, the Chinese displays at UAV displays at any of the Olympics or anything? They are mind-boggling.
Yeah.
So if we just take that and apply that to the potential warfare, applications against the United States, wow, we should all be concerned about, just like you said, and the expenditure of high-cost missiles against, cheap drones. We have to have a counter-drone solutions that are going to be effective and inexpensive.
My take in the short term, like, because again, we need to do a lot of stuff to make this work. Like, air-to-air interception is an incredibly difficult thing to do, and it's expensive. But in the short term, we should build a really good offense, like a really good offense. And that means we should be building stuff at $50,000 to $100,000 a ticket, so that if they get into a situation where they want to go toe-to-toe, we have 20 different vendors. Again, we need the entire industrial base doing this. Basically having a wall that we use as deterrence. A lot of people on Twitter are arguing that drones are the new nuclear weapons. I wouldn't go that far, but if you look at what I think it ended up being 25 Ukrainian pilots using drones in Syria were able to do to Assad's army in 8 days, that should be the wake-up call for kind of the world, in my opinion.
I thought the sinking of the Moskva was really just very impactful. Here we were in our entire Cold War career thinking about the Moskva being this terrifying ship, the Russian fleet's most tactical and biggest threat to the United States, and it was taken out by a drone. A little swarm of drones for a distraction, and I think a UUV, if I'm not mistaken. Maybe you guys have more information on that.
Again, this is second-hand information, but I was told for about, we'll call it $200 million, and I've probably rounded up 50 million. They were able to build and deploy at mass, an unmanned surface vehicle program with the Ukrainians to destroy 30 to 40% of the fleet. And if you guys are there on your phones, you can just Google ski don't, okay? A couple of these things lost their Starlinks and ended up drifting into Turkey, so they have pictures of ski-doos that they put Starlinks, explosives on, and that's what they used, right?
So, we're thinking about it, we're talking about asymmetric warfare against large conventional weapon sets like we have in the United States. So we should be thinking about what are our counter asymmetric capabilities.
I'll share this with you guys. This was the first time I've ever heard this. These Ukrainian pilots we had in the office on Friday told me they've killed a bunch of North Koreans and they're going through their stuff. The North Koreans have books on how the Russians are deploying drones. So they're stopping, this is what they're finding. Imagine what the North Koreans have sent back. The point is, the genie's out of the bottle on the use of mass deployment of asymmetrical technologies into more legacy maneuver type elements. And I don't think it's going back in anytime soon. So we should be thinking the same way.
I agree. I think just one more thing. I think the application of those Olympic demonstrations that we see, that the AI behind that, what does it take to control swarms of drones, 10,000 drones? So I think that's the part that I think we should also be paying attention to, not just the hardware, but also what's the AI behind controlling massive swarms of drones. And I've actually opened it up, by the way, to the chat for questions, so I'll check that.
Yeah, please. We want to make sure it's free flowing because this is really you getting from the boots level information what the war fighters want. Of course, we got to deal with the acquisition side in the middle, but that's where we come in. But the point we're trying to make is we need to get the stuff that you build out to the fleet as fast as possible. Go ahead, Virginia.
In the 1980s, I worked with VC6, a composite squadron that produced drones, the BQM-74C at the time. It was produced by Boeing. I'd like to know the OEM that you have a special relationship with.
It's a big industrial 3D printing company.
Yeah.
It's publicly traded. I can sidebar with you if you'd like.
That's important though, because it's speed, right? Speed is not just getting things off the production line. It's the culture of the organization.
Yes.
And that's why having companies like these the CEOs, they can make decisions fast, but having the CEOs talking on the same table, trying to figure out a problem, things move very fast.
Yes.
So we don't answer to, at
In
least
the
for me.
80s, we were working on the photographic technology to take the pictures, and we were also working on weaponizing them. That was in 1987. I went up to Boeing in 2004. They still had a static display of the same drone. The acquisition life cycle is too long.
Yeah, we know this, but you know, it's not
Amen.
their fault. You know, it's the customer.
Yeah.
The customer drives the decisions of what we buy, because we have to respond to the customer. What I'm hoping is, and I see the camera out there, that the customer responds to what the warfighters want. So, I want to cover cyber also, and critical infrastructure, because critical infrastructure in the host country is important because we use it, the U.S.
Yeah, I think anything that intersects, right? Whether you're in one country to another or what building you're using, all of these are components that we monitor. I mean, it's a digital footprint. Anything that has a footprint, you need to monitor, and I think that's part of recognizing reducing the supply chain or the components and making it modular is going to be critical as we get into putting stuff in front of the warfighters. The other thing is I think Mel kind of alluded to is, you know, we're very nimble and we are able to go to our clients in any places, but we also work with many of the large organizations. And believe it or not, there are things that I was able to go meet, like the general, and was to complete a conversation and agreement in a matter of days and a couple of Arabic tea, whatever it is, versus when we engage like, you know, a large company, our interest and our conversation cycle became a political game and land grabbing real estate versus what we're trying to do. And it's the same thing here in the States, I guess I could say that. You know, I think there's a lot of companies like Dana and myself that we are patriots. We want to do the right thing. We want to make it right. We want to make it cost effective and not have all of these cushions that people add on, because at the end of the day, we're trying to, you know, protect our country, and we want to put the right things in front. And, you know, good or bad, that's just the reality that Dan and I live in. And it's unfortunate. It's a big journey. And everybody tells me, like, how long the SAMs, you know, the process is. And, you know, that's why we only do sole source. But I think there's a lot of things that we could do. I mean, you know, you guys are a very large, complex organization. I have utmost respect for everything that you guys have to do. But I think we could minimize that time to delivery, efficiency, cost, and bringing the right solution to the warfighters quicker, faster. And I think it's important to have somebody like Mel to.
Yeah, the value I bring, I guess, to this table is I can get things out to the fleet faster because of the contracting vehicles, but so can you folks. Find these I call it unicorns that you see, okay, we need to get that things out. Don't think about the acquisition contract. I mean, yeah, we got to work through those folks. I was one of them. Think about how to get that stuff out to the warfighters as fast as possible. Case in point, we talked about asymmetric warfare, a swarm, million. Well, I can tell you about one small hobbyist quadcopter that took down 3,000 people. And this was in 2016 in Baghdad. A little copter flew over the U.S. Embassy in Baghdad, and we all had to hunker down. Talking about 3,000 folks going straight into the bunkers. Talk about a soft kill. And it was just a little quadcopter you can buy on Amazon. But what it has is a little chemical thing that it drops. Well, that scared everyone, including the ambassador, the chief of mission, the generals. So one little copter can do that. Imagine what a million can do. That would scare a lot of folks.
And I think, all joking aside, all the components, I know we talk about nation state, China, Iran, and all these things. The reality is that all of these components that make up our military assets are already being targeted by criminals, because criminals are the agents of nation states or sponsor people, and their job is to infiltrate. I mean, we have clients that's being infiltrated by, you know, the North Koreans. We have people that are being placed by countries to be working in reputable Fortune 100 companies. It's a reality that goes back to zero trust that it happens, and technically it's all supply chains.
I want to continue with this cyber thread, then I'll go over to you. We'll try to speak as much as we can, but some of us on here on stage have been to Albania, helping their country protect themselves against and you can Google this, 2022 Albania cyber attack, is unclassed, it was Iran. Again, because it's unclassed, I can say that. Very, very well coordinated, massive IT and OT. If you're not familiar with OT, Operation Technology Cyber, that is something that is, we are vulnerable. I'll just say it right out. But protecting the host country's infrastructure is critical because our troops are there using that. Same thing in Iraq. We had our troops using the Iraqi Defense Network. That's their SIPR, IDN, totally compromised by ISIS back then. And so, unfortunately, we had a lot of ambushes against the Iraqi troops that didn't come home because of stuff like that. So, protecting the critical infrastructure, cyber, it does cause damage.
But one thing I would say with Albania, a lot of these breaches that we hear about, it's not that exotic because there's a lot of defects that people forget to fix. And Albania is one of those cases. When Mel talked to us about it, I think we were able to find it in an hour where it actually originally started because it's not that complicated. I know there's really complicated, sophisticated attack, but majority of it, it doesn't require a lot of work because our network are very porous in general.
Last one, I'll turn it over to Dan, so I can talk all day about Albania and cyber. One thing I learned, lesson learned from this, Security Operations Center, SOCs. Great, a lot of folks want to cut costs, so they do a remote SOC. So imagine having a SOC in Texas. What is the first thing the hackers will do? Cut that line. Now you have these folks blind, can't see anything, they don't know how to fight because all the training is done, was not done there. It's being done by the US folks in the United States. Well, these guys, they think like a hacker. They'll just cut that thing off, and it was mass chaos in that country. So I'll just leave it at that. Sorry, Brian.
So Mel, I just had a question for you. Why was Albania the target of China during that time?
Well,
What's the context?
We'll talk around it, but so again, this is unclassed. If you Google Ashraf 3, ASHRAF 3, there are 5,000 Iranian dissidents in Albania. That's the second, basically, if the government in Iran goes down, this one will replace it.
So Albania is a Muslim country?
It's a Muslim country, but it's also a NATO country. And so NATO's building building a base. I mean, if you look at where Albania is, strategic location for supply chains that goes out to Eastern Europe.
Right at the entry to the Adriatic Sea. I was there in '97 flying missions with Operation Silver Wake, and I think a lot of refugees were streaming across the Adriatic into Italy. So I think it was a huge catastrophe. I don't know where the country's gone because I haven't paid much attention. That's why I was asking, what's the context today? And I didn't realize so many Iranian immigrants had moved to Albania these days.
Yeah, and I've been, like I said, we've been to Albania a lot, but I spent a lot of time at Ashraf 3 trying to protect their cyber networks. It's basically a compound, I call it more of a palace, within the country of Albania. It's just 30 miles north of Tirana, the capital. But it is attacked constantly, not just non-kinetically cyber, but mujahideens would come in, people from Iran with AK-47s, just going crazy. EMP devices, electromagnetic pulse devices, I thought it was just something, on paper. Oh no, it works. It took out data centers, it also took out vehicles, and it took out the air traffic control at the international airport in Albania. So I'm presenting this because, in my opinion, they're using this place as a playground to refine their TTPs before they go big. So that's why it's important to protect the critical infrastructure. I want to turn it over to Dan about what the risks are if we go into a country that isn't protected by Gene's company.
Yeah, I mean, I think it comes back to this idea that, physical goods can be influenced by, you know, let's call it the non-physical world, so like cyber. And I think that's one of the big concerns, and you're seeing the DoD really aggressively push people to buy NDAA compliant stuff, but we have to make sure the NDAA compliant stuff and we'll call it non-CCP'd factories where some of the stuff's coming out of, have that type of resilient cybersecurity on the back end, right? You know, I know a couple folks who are basically trying to establish like almost like an Alibaba, if you will, of non-CCP factories in Taiwan, because that's where now a lot of people are looking as China has closed the component door for UAVs, but there's still risk there, right? And you know, if you guys have been to Taiwan, like there's a lot of Huawei stuff there. So we have to be thinking like bigger picture when it comes to it. Just because it has a stamp saying like this was made in a factory that the CCP has no ownership in doesn't mean we're actually safe.
Yeah, I think we're becoming desensitized about, hey, there's another hack or another breach, you know, millions of credentials exposed. I think this is just the tip of the iceberg about what's about to happen. Based on what we've seen overseas, we need to protect our critical infrastructure. Another thing I want to kind of point out is updating the manufacturing of your UAVs overseas. How, you know, software.
Yeah, we've designed it so you can actually like, it can be connected, right? Or it cannot be connected. And so if you want to do an update to the design, we could literally hand it to you and then you could put it through whatever channel you want to take it to the location it's at. Or again, if you have some sort of like constant data link, that's the opportunity. But we really have designed it to do both, knowing that there's going to be instances where, you know, you don't want to be on the net, if you get my drift. But that's really the kind of the really cool thing about this technology, is it allows you to kind of turn on or turn off connectivity depending on what you need.
Awesome. Jeannie, anything?
No, I mean, it's, you know, thank you for your time. I mean, it's interesting to hear everything you guys have to say, because I come from the private sector, so it is somewhat eye-opening sometimes. So, Dan.
Yeah, thanks. Very interesting presentation. Curious when you mentioned counter UAVs, kind of like the framing is all shooting it down, and is there not as much of a play in signals exploitation and or, I don't know, localized EMP or anything like that that would be, you know, not a traditional shooting it down type approach?
Yeah, I think, let's just say this, a lot of the RF stuff that the US buys that it is sent to Ukraine is not working. I've been told just point blank, like program of record systems. I think that, again, when you're fighting, let's call it armies of PhDs, they're making modifications to like what the signals and even what the packets have that like allow you to kind of adjust on the fly in a way in which we never saw when it was 98% of the threat was, you know, stuff you'd buy at like Best Buy, right? So yes, absolutely. I think the EMP black box, like if we open that, it could get really scary, a bunch of flying around EMPs. But who knows if that's where we end up. Maybe I'm just a little pessimistic, you know, talking to guys who are like, yeah, counter-UAS system works great. Russians basically move the entire, you know, 30, 40, 50, 100,000 drones, whatever number you look at, a month to a completely new set of channels, and everything we've built does not work, right? It gets worrisome. And then you can also, if you guys are following it, they're starting to use fiber optic cables. And some of these Ukrainians have told me they hit a Russian tank 25 kilometers away using a fiber optic cable about 2 weeks ago. I mean, now you have to actually have a quadcopter like they have for the ISR drones. They have these fleets. They call them like air wardens, right? So they're looking for these ISR drones to go kinetically run into, and then they have these shape charges that detonate to try and knock them out. They're now building a version of that for the optical drones. So they basically are like, what video link, like we can't see anything. We almost have to just, because there's no video link back, right? You almost have to like take that listening approach and just listen for the whirl of the quadcopter. So, I mean, that's the level of like iteration we're seeing, you know, and a couple months ago, we didn't see fiber optic drones anywhere, and now they're everywhere.
I want to talk about battlefield innovation, and this goes back to Baghdad. So we used most of the stuff that was sold, you know, the EMPs. We also used nets. And if you ever see the nets that go out and shoot to take out drones, didn't work. What worked is we went to the British embassy in Baghdad because we knew that if you're familiar with the Gurkhas, familiar with Gurkhas? Okay, so we knew the Gurkhas were using a device that was 100% effective. It was hawks, real live hawks. These hawks would kill these drones 100%. Can't beat it. So that's the kind of stuff that goes on, I guess, on the battlefield. And so we need that same sort of speed capability to do these things. Now, of course, you can't take out 1 million, but if you're talking about targeted, this kind of stuff works. So let's talk cyber about taking out drones.
Yeah, you know, there's a lot of chatter in general about all the components, even payloads that they're creating, and to implant these payloads into these devices and every facet of the drone manufacturing. And then there's the people that are actually embedded into companies to monitor all of these things. I mean, like NVIDIA has massive insider threat. Okay, let me rephrase this. There's a lot of companies with lots of insider threat, and these are foreign adversaries that's implanted and do these things. So when I know we always talk about cyber as some hackers and targeting you with some 0 days or exploiting your vulnerabilities. Those are what the kids do. That's not what the real criminals do these days. They work together. They specialize in activities. I would say, I mean, we monitor over 40 million-ish hackers, you could say. Out of that, I would say 97% of them are kids, everybody under 24, 26 around there. And they're very good at doing repeatable things. Like the IGRC is very good at doing password spraying attacks. And that is not a specialty. That is just a very low-level stuff. And then we got the 2%, what we call the technicians, that actually has obtained a key, enters into your environment, and that's what we call the technician. And then you got the 1%ers out of the 40 million-ish, which we call the specialists, and they are what we call the mercenaries. They stay persistent, highly paid. We know many French operators that are paid by French government. Am I supposed to say all this? Never mind.
You're fine. He's Silicon Valley, so.
I know, Los Angeles, Hollywood, all right? Yeah. But we know there's people that, like we know some team that's from Middle East that reside in Japan that sells 0 days. All of these people are in play, and it's very open to people who, in my business, because we're in the business of monitoring all these criminals, and they stay persistent and they exchange 0 days. And, you know, a lot of these things are very commoditized. And it's available. So it's anytime they want to anybody wants to shut down an entire grid or disrupt an environment, it's there. It's just somebody wanting to say go or no go. Like if I wanted to disrupt a state of Texas or state of California, I would go after all the hospitals. Why? Because it creates chaos. And they have the similar mentality. So when you see like these targeted hackers attacking these things, that's not real attack. Those are things that's already happened and just covering up their tracks. Just what we see from our industry.
All right, I was going to wrap it up and just kind of go down, but please.
Real quick for Dan mostly, I think. One, just are you engaged with Project Replicator? It seems like you're, well.
Replicator's been very interesting. There's 4 drone companies on contract for Replicator. They've not expanded it beyond that. We are not one of them.
Okay. My other question is for your connectivity. What RF spectrum do you typically use, or do you have flexibility in terms of spectrum? Or
yeah, exactly. We've designed our UAVs so you can put, like we're integrating new radios in a day, right? So you can go from Silvis to stuff that works longer range. It really just kind of depends on what you want. We've built it to be that modifiable, right? And there's obviously a little bit more intricacy, right, from like an antenna standpoint as you make the modification, but we've designed it to be modular from the ground up. There's some stuff that works extremely well in Ukraine, extremely well. It's very expensive, right? But remember, extremely well over there might mean 10 to 15% success. And so we have to reframe our understanding of this, that a contested EMI environment is going to be the new standard. The other thing too is there's no GPS. Okay, full stop. So you have to just have that as a table stakes when you build this stuff and assume that you're going to need to use a lot of systems to kind of get to where you need to go.
Perfect. Gene, I think we're wrapping up, so if you got any last thoughts, and then.
Go ahead, Dan.
No, thanks for having us today, guys.
Yeah, it's too bad the replicator well.
I just
That-
had
yeah,
one
go ahead.
question, real quick. So one of the things also we hear from Ukraine in the beginning, they captured some Russian drones that had recorded where they've been, so they could reverse attack them. So you also do that, like protect the drone from capture. So
That's a huge issue, right? So guys, a lot of the digital signals are jammed immediately, so they move back to analog, but because it's analog and it's not encrypted, the Russians literally were like, they will grab those signals and watch the drones come back and then go kill the kill teams. And those are like what I was told, those are like the kill teams, the drone kill teams are some of the most high value targets in the war now.
Okay.
Yeah,
But
if you're not
also
used.
So they launch and then they move and then they land it somewhere else. That's kind of the MO they've had to build.
Yeah, but also the storage, right? If you record a number of things, then you also know where they came from.
Totally.
Okay.
I've been hearing a lot about moving into the HF spectrum. Are you guys seeing that?
Yes, it's super interesting. Like it's almost like everything we thought was going to be where the fight would be 10 years ago.
Exactly.
It's just totally gone.
I mean, during kickoff 2001, right after 9/11, pretty much HF had died, and it was dead for a while. But we're seeing a resurgence in the use of that spectrum today.
We're seeing HF. We're seeing some pretty interesting stuff too, where they'll actually have SIM cards. Okay, and so for some of these deep strike attacks, you guys might read about, instead of going from like Ukraine to an oil field 1,000 miles away, they'll go 80 kilometers an hour and they will follow roads so that when they get into Russia, it looks like it's just a car because it's moving at that speed to get to where they need to go. I mean, this is
Tactics.
the level of
Tactics, right?
This is the level of complexity that they're going for.
And so, what I keep hoping is, and it sounds like we are paying attention to the lessons learned from Ukraine, because we look like Russian conventional forces.
Yes.
Yeah, that was kind of the feedback the Ukrainians gave us, is like,
Hey, you guys look just like them.
yeah, when the North Koreans showed up, their conventional force, and like we crushed them. They were not ready at all.
Well, I hate to say, because this has been a fascinating panel, I would love to go on again. I've invited Mel and the team to come back out to Don IT East in May 12 to 15 out in Norfolk. So hopefully we'll have a repeat, continue the conversation there, and of course, by all means, stop by afterwards and have a chat with them. We have to wrap, but we're going to pick it back up at 1300, 1 p.m. for everybody, and it'll be Dr. DJ Shai. He will be talking about dynamic spectrum sharing. So, gentlemen, thank you so much for your time today and fascinating discussion.
Thanks,
Thank you. I appreciate it, folks. Mahalo.